So something about me, I'm Siddhant. I'm a student. I'm a third year undergraduate student, and I'm an intern at Deep Source. At Deep Source, we build code analyzers for various programming languages. So we have just now released the JavaScript code analyzer. It's in beta. You can surely try that. And I like to contribute to Babel in my free time. And I have been a Google Summer of Code 2019 student with Public Lab. And currently I'm like interested about compilers and what are their applications in the JavaScript ecosystem. How do they actually work? So, so the first question comes up, what is Babel? So if you ask Dan Abramov, whom we all know as he is not the creator of React.js, so he says Babel is the new jQuery, okay? To which Jed Schmidt replied that it's reassuring that he saw it coming, and jQuery helps you manipulate the DOM, and Babel turns the code you have into the code you need. So he said that Babel is to JavaScript as jQuery is to DOM. To which Kent C. Dot replied that Babel is to AST as jQuery is to DOM. Like as jQuery manipulates the DOM, Babel manipulates the AST. You must be thinking, what is AST? We will surely talk about it in coming slides. So hang on. So this is a sneak peek into the Babel repository. It's an open source project. It has around 37,000 stars, and it's a pretty cool project. And what does it about section say? Its about section says that it is a compiler for writing next generation JavaScript. Okay, let's see what that means. So firstly, what is a compiler? So according to Wikipedia, a compiler is a computer program that translates computer code written in one programming language into the another programming language. And mostly the destination programming language is of a lower level language, like assembly or a machine code. As an example, here we have the C code, which has been compiled into an assembly code. So Babel is a JavaScript compiler, right? Does this mean that it converts JavaScript into assembly code? Magic stuff, yeah. So it converts the JavaScript code on the left into assembly code. Is that right? No. Babel is a JavaScript to JavaScript compiler. So it converts one form of JavaScript into another form of JavaScript. So what Babel actually does is that it converts the new syntax of JavaScript into the older syntax, but with the same meaning. So it's more of a transpiler. So you must be thinking like, okay, it converts my new syntax of JavaScript into old. Then why do people say that it can be used with TypeScript and Flow? So the fundamental use of Babel, that because of which it was made, was to convert ES6 to ES5 or the older versions. So just to give a brief definition, it helps us convert the new syntax of JavaScript into the older one. You must be thinking, but why is it needed? Why do we need to compile JavaScript to JavaScript? If I compile JavaScript to machine code, then my software would get faster. Why would I need to compile the same language to the same language? So here are some of the reasons. Firstly, backwards compatibility. So not all browsers right now implement ES6 features or the newer features of JavaScript. And if you are running a software company, you don't want your software to break on older versions of browsers. And yes, around 4 to 5% of people currently use browsers which run ES5. So Babel can help your software run on that browsers. Syntax transformation. Babel has support for all the latest version of JavaScript through syntax transformers. Even if they are not implemented in browsers, you can write the newer version of JavaScript and its experimental features in your software, and Babel will take care of transpiling it into the older version. It also supports JSX and React through Babel preset React, and it also supports type annotations, Flow, and TypeScript, which are two typed language, one by Facebook and one by Microsoft. So it has presets to like transpile them to whatever kind of JavaScript we want. So here is a short example. On the left, we have the JSX code. It is a short JSX code. And on the right, we have the transpiled JavaScript, which has been transpiled by Babel. And you can see that it's pure JavaScript. So this is what Babel does in a basic way. Also, Babel helps us to make awesome code mods and plugins. What are code mods? Code mods are the tools that help us to refactor large code bases. For example, you have a very large code base and you want to refactor and you have a certain pattern of refactoring. You can use code mods to do that, and you can make code mods using Babel. And Babel offers some great plugins which can help us to do a lot of optimization in our code. For example, this is a very famous plugin, Babel plugin Lodash. So on the left, you see that we are importing Lodash and we are importing add functionality from Lodash. And we are using it, but we can optimize it. And Babel plugin Lodash does that. It does that by importing only add and map functionalities from Lodash and nothing else. So in a way, it helps us to make the source code somewhat faster. Also, Babel helps in evolving JavaScript. As I said that the TC39, which is the standards body, and it maintains and evolves the definition of JavaScript. It works on new features which have to be implemented. So when they have implemented the feature, they need to test it out. Like, what is the community response? How does the community respond to that feature? Do they like it or do they not? Implementing the new features in browsers takes some time, but in Babel, you can implement it somewhat earlier. So what developers do, or the champions who write the experimental features, they also implement those features in Babel, and they get community response. How does the community like the feature, or community feedback for the feature? So in a way, it helps in improving and evolving JavaScript also. There are many developers tools that are powered by Babel and which use Babel. Some of them are ESLint, Webpack, Prettier. Like, all of them are very famous and they are great tools. And similarly, there are many developer tools which use Babel under the hood for some of the functionalities like parsing or transforming. Babel has a language support for all these languages: React, JSX, Flow, and TypeScript. And now comes the real question. How does it actually work? Let's go inside. So firstly, whenever we need to understand the compiler, we need to understand what is abstract syntax tree, or AST. It is the heart of a compiler, and it is a data structure which is used in almost every compiler. It is the tree representation of the abstract syntax of the source code written in a programming language. So if you write a source code, how does the machine understand it, or how does the compiler understand what you have written? It is through abstract syntax tree, through which it understands the code you have written. And why is it known as abstract? It is known as abstract because it is independent of any representation of your source code. So it does not have any data about the white spaces or about the exact look of your source code. If you want to use a tree which has a full representation of your source code, you can use concrete syntax tree, or CST. Most of the formatters, I guess, use concrete syntax tree. So here is a small example of how you can make an abstract syntax tree for an expression, or how abstract syntax tree actually is made for an expression. So on the left, we have a small expression, 1 plus 2. In order to make its abstract syntax tree, we have the first node, which is the binary expression, and it has its value as plus, and it has two children. The left child is the numeric literal, which has the value 1, and the right child has a numeric literal, which has the value 2. So this is like a very small example about how abstract syntax tree gets implemented. Babel has its abstract syntax tree in the form of a JSON object. So you can see the same expression on the left and its AST on the right. So The first field is type, which is binary expression, and then we have three properties: left, operator, and right. So the left property has the data about the left part of the operator, and the right property has the data about the right part of the binary expression. So left property has the type numeric literal and has value 1. As you can see, the left numeral is 1, and the right property has the type numeric literal and value 2. So this is a small example about how Babel has its AST. It is in the form of JSON object. Nodes. Here we see that this full thing, which has been implemented for this expression, we call this a node. So an AST can be made of a single node or hundreds or not thousands of nodes. So if you have a lot of expressions, like in a code, we write a lot of expressions, and each expression has its node. So if you have a binary expression, you have its node. Like in the example, the first example, this node is of a binary expression. The second example is of a functional declaration. If you, for example, implement a function A, and you pass some params, and you have some body in that function. So the node that gets implemented for it is of the structure given in the second block. If you have an identifier, like for example, if we define any variable, let a equal to 10. So the node for the variable a will be of the type identifier and will have the name as a. So similarly, when Babel parses the source code, it makes a lot of nodes of each expression. Nodes is called an AST. So here is an example. Let's see how it works. So for example, we have a small code on the left. It is a very simple function to calculate the square of the number that has been passed. The AST that Babel makes of this function is given on the right. But let's see, how does this AST actually gets made? So firstly, we go to the function, and as we discussed, we make the function node. Function has a type, ID, and params. Then we go to its name, square. Okay, and we have its param, which is n. So we add the type and name to the ID object, and params, we add n to the params array. Now, after we have parsed the function expression and the function name and parameters, we go into the body of the function. So the body of the function is a block statement. So we give the type block statement and we add a body array to it. Now we have a return statement in our body. So a new node of the return statement is added into the body of the function. So we add the type return statement and we add an argument object to it, because every return statement has an argument object to which arguments it is returning. And finally, we add whatever the expression we are returning from that function into the arguments object. So for example, here we are returning a binary expression from this function. So we have a type of binary expression, an operator star, and we have the left and the right operands n and n, which are both of identifier type. So this is how the whole AST gets formed. Like we discussed it of a very simple expression. It is just a function expression. There are a lot of types that Babel parses, like arrow function, like comments, the leading comments and the trailing comments. So you can find the list of all the types on the Babel website. There are a lot of them. So how does Babel actually parses the AST? We got to know like how the AST looks and how it goes to each component of the source code and parses it. But how does it actually do that? So here are the steps that Babel takes to parse the source code. So firstly, we give the input source code to it. It converts it into an original AST. Then it applies transformation to it and gives us a transformed AST. And then we get the output source code. Okay, so these are the steps that Babel takes. And the components of Babel that help us to do them are these main packages: Babel parser, Babel traverse, and Babel generator. So Babel parser does to parse the input source code and gives us the original representation of the source code in the form of an AST. Babel traverse does to apply the transformations that are needed on that original AST and gives us the transformed AST. And Babel generator finally converts the transformed AST into the output source code. And all of this functionality can be used by a single package also, which is known as Babel core. It is like an entry point for all of them. So let's start discussing each package at once. Firstly, we start with Babel parser. Babel parser has mainly 3 steps: lexical analysis, syntax analysis, and semantic analysis. In lexical analysis, it converts the input source code into tokens. In syntax analysis, it converts the tokens into an abstract syntax tree. And in semantic analysis, it converts the AST to the AST we need after looking if it has some errors or not. So lexical analysis. So there's nothing in this, just converts the source code into the list of tokens. So for example, we have a simple expression, const answer equal to 42.
Siddhant, if you can remove your camera, because the slides are not showing for some people. Maybe
Okay.
it's a bandwidth issue. Can we try that?
Sure.
Yeah, okay.
Okay. So yeah. So firstly, we have the token of keyword and it has the value const. The second token is identifier, which has the value answer. Third is the punctuator equal to, and fourth is the numeric of 42. So these are the tokens that have been generated for this expression. Next, what it does is syntax analysis. It converts the list of tokens into an abstract syntax tree. It also handles automatic semicolon insertion. For example, generally we do not write the JavaScript that has semicolons. So it also handles like where semicolons are needed and where semicolons are not needed. It also reports about error about misplaced tokens. So for example, this expression as an example we can take again. So if we have to make an AST for this expression after we have got the tokens of it, first node that will be made will be a variable declaration and will have a value const. It will have a child variable declarator. On the left, there will be its child ID, which has its child identifier, and the value of identifier will be answer. And the right child will be numeric literal, which has its parent in it, and the value of numeric literal will be 42. Next Babel does is semantic analysis. So after we have got the AST of the source code, Babel checks that if that abstract syntax tree honors all the static ECMAScript rules. So it checks if any variable which has been declared with let, it has already been declared or not. It also does scope checking. So if variable is in global scope or variable is in local scope, and it reports error if there are some invalid variables found which like do not obey the laws of scope or which are like ruining the scope. Here is the Babel parser API. So you can use Babel parser by just requiring it and just use a dot parse function of its API and pass the code that you want to parse. And source type, if you are using ES6 modules in your project, then you have to pass source type module. Else Babel takes default script in source type for CommonJS. Also, you can pass plugins for enabling some syntax or experimental JavaScript features which you want to parse, and Babel will do the work for you. Next package of Babel is Babel Traverse. It provides us a declarative way to visit every node in the AST, or it helps Babel to visit every node in the AST. It maintains the overall tree state and it is responsible for replacing, removing, and adding nodes. So, for example, when Babel needs to mutate the AST or transform the AST, it needs to add the nodes and it needs to replace the nodes. You can do this, and Babel does this with the help of Babel Traverse. And it uses depth first search. In two ways it can do that, in order as well as out order. In order, you go to the parent first and then to the child nodes, and out order, you go to the child node first and then to the parent. So here is an AST. Let's see how Babel traverses it. So Babel enters the variable declaration, then enters the variable declarator, then goes to the left child or the identifier, and then goes to the right child, and then it exits each node. So this is the way how Babel traverses the AST. Another important concept which is important for Babel traverse is visitors. So when we talk about going to a node, what we actually mean is that Babel is visiting that node. And how is it visiting? With the help of visitors. So a visitor is an object which has methods defined for accepting particular node types in a tree. What does that mean? So here is an example. For example, if you want to parse a source code and you want to log called for every identifier, like if your code has 9 identifiers, then the program will log called 9 times. So what are we doing here? We are making a visitor object, and in that we are defining a function for identifiers. And whenever Babel will go to an identifier or Babel will find an identifier in the AST, it will log called in the console. So this identifier which we have mentioned here, it is a shorthand for the identifier or the API which we have seen in Babel Traverse. Paths. So an AST generally has many nodes, but how do these nodes relate to one another? They relate to each other with the help of paths. So a path is nothing but an object representation of the link between two nodes. So for example, on the left, we can see that this is a node and it has a type function declaration property, and it has its child identifier and which has a name square. So how does the identifier relate with the function? On the right, we can see that the identifier has a parent which has the type functional declaration. So this is the way that the nodes relate to one another in an AST. A path not only has the parent information, it has a lot of metadata about the abstract syntax tree, which can be used for various functionalities like adding, removing, or replacing nodes. Paths in visitors. This is the third most thing after visitors and paths. Paths in visitor is like when we have a visitor that has an identifier method, we are actually visiting the path instead of the node. Like as an example, which we saw in the path in the visitors slide, we were using the identifier function to log in the console called whenever we found an identifier. But it was not actually going to every node. It was traversing the path and it was logging in the console whenever it has found that identifier in the path. So whatever functionality you can do in Babel Traverse, you can do on the path. And every path has its node. You can mutate the nodes also by using the path.node.name functionality. So here is the example. As an example expression, we have taken a plus b plus c, and we write a visitor for it, which will log visiting and the name of the node whenever it visits any identifier. So here we have 3 identifiers, a, b, and c. So whenever the Babel Traverse visits the AST, the identifier node of the AST, it consoles visiting A, visiting B, and visiting C. I mean, they can be somewhat complex at first, but when you understand them, like you can really do a lot of changes in an AST according to your will. So this is the Babel Traverse API. So nothing complex here. The API is very simple. You need to call the traverse function and you have to pass the AST, and by default it enters the path. And here is a small example which I have written, like if the type of the node is identifier and type of the node and the name of the node is n, then we change the name of the node to x. So if you write a code and you have declared a variable named as n anywhere, this traversing will change the names of all the variables with name n to x. This is a very simple example about Babel traverse. Finally, Babel generator. It is the third and the last main package which helps Babel to generate the output source code. And it is the code generator for Babel. It takes an AST and turns it into code with source maps. After you have transformed the AST according to the options passed, you can generate it into the output source code with the help of Babel generator. The output is not a prettified one since humans don't have to interact with it. And if you want an output which is prettified, you can use Prettier. It is a pretty printer. This is the Babel generator API. A simple example about how to use it. You import parse because you need to parse the expression in order to generate it, and then you import generate from Babel generator. Next, you define some code and you parse the code into an AST, and then as the last point, you can just get the output code by using the generate function. You pass the AST and you pass the options with respect to which you need to get the output source code, and you pass the code option, the code which you initially passed. It will get you the output source code. Babel core, as we discussed, it is an entry point for everything that like it is used by Webpack parcel to like use Babel functionalities. It has all the three packages in it: Babel parser, Babel traverse, Babel generator, and it merges all the local configurations for transformation. So you have to make configurations for using Babel also. You can make them in the form of babel.config.js, babelrc, package.json, or in the JSON file like you do in ESLint or in Prettier. So how to configure Babel for my project? So a config needs to be added to the project similarly like we do in ESLint and Prettier, as I said. Here is a small skeleton of the Babel config. We just write the presets and plugins which we need to use, and Babel will like give you the output code with respect to the options we have passed here. There are many more configuration options. You can find them at this link at the Babel docs. They're great. You must be thinking, what are Babel plugins and what are Babel presets? So Babel plugins are actually the thing that helps Babel to do anything that it does. So for example, we know that Babel helps us transpile TypeScript to JavaScript. So how does it do that? It does that with the help of Babel plugin transform TypeScript. So without plugins, Babel is just a simple parser and generator. It will do nothing to your source code. So we need to do plugins. We need to add plugins for Babel to do anything. And the great community of Babel and great community of developers, they have made really awesome community source plugins. You can check them out. Also, so there are somewhat Babel presets. Babel presets are like a collection of plugins for a certain use case. For example, you want to parse or you want to transpile React code or React JSX code, but you don't know which plugins to use. You can just use the Babel preset React, and it has all the plugins that are needed to do that, and it will do that without needing to like specify each and every plugin. So this is a big relief. Next, we have two more bonus packages, Babel types and Babel templates, which are really important for the Babel ecosystem. So Babel types. Babel types is a utility library for AST nodes. What does that mean? So it contains methods for building, validating, and converting AST nodes. So for example, you are going through an AST and you want to validate that is that node a identifier or is that node an arrow function expression? You can do that with the help of Babel types. It is useful for cleaning up AST logic with the help of well thought of utility methods. Like the methods are like quite easy to understand. Like node dot is identifier, like you get to know that it is validating that thing. So it it helps us to like easily do the things. As an example, we import traverse from Babel traverse and we import Babel types. Then we traverse the AST, we enter the path, and if T dot is identifier, here we are validating a node. So T is Babel types and is identifier is a function or utility method, and we are checking if that node is identifier. Then we change the node's name to X. There are various methods. T dot is call expression, T dot is catch clause, is conditional expression. You can check them out on the Babel types documentation. Babel template. This is the second bonus package in Babel. It is really helpful. So for example, if you want to like transform a certain template of source code into something, you can use Babel template for it. In computer science, this capability is called quasiquotes. I got to know that today. It's a neat notation that lets us to manipulate the AST with ease. So here is a small example. So if you want, like we import any package in our JavaScript files. If you use CommonJS, we import them like var package name equal to require and source. So if we want to change the import name of every JavaScript file to customized name you have, like my module, and if you want to change the source to something, so you can make a template of that and you can use Babel template to do that. So here is an example. We are making a template in the first two lines, and then we are getting an AST after changing the import name to my module and source to the small my module spelling. Yeah. So, and the last, we are generating the output source code using the generate function. So it will change every require statement into my module, where my module equal to require my module. Okay, so we have discussed a lot about how Babel works.
2 more
Let's,
minutes.
okay, 2 more minutes. Okay, so I have actually written the plugin here. I have already written. So it's nothing like too hard here. We are using the syntax which Babel has provided to us. Like Babel asks us to write the plugin in this way because it has exposed some API functions. So we are exporting a default function and we are using Babel types here, and we are returning a visitor, and whenever it finds a binary expression and checks that if it is not a triple equal to. So let me just show it. So if you are writing a function hello and you're writing if a triple equal to b word, you just call a function word. So it converts your code into if Peter Parker equal to Spider-Man. So whatever you write here, whenever it finds a triple equal to statement, triple equal to binary expression, it converts the left and right nodes into Peter Parker and Spider-Man. So this is like a very simple example that I thought to give for this talk so that everyone can understand. So I'm doing nothing. I'm just finding where the operator is triple equal to, and I'm changing the left and right identifiers to Peter Parker and Spider-Man. So this is just a very simple plugin. You can surely try that. Like there are many interesting plugins out there in the ecosystem. Do check them out. And one more reason to check them out is because the Babel plugin hackathon. You can follow Henry. He is the Babel maintainer, and he recently tweeted about Babel plugin hackathon. You can surely join the Discord channel. And this is the list of the core maintainers of Babel. And Babel is a project which is being maintained by volunteers. So you can surely, and you are welcome to help out. You can either give your developer time on the project, or you can, if your company uses Babel, then your company can maybe fund them, or you can sponsor them on Open Collective or Patreon. And if you want to contribute to Babel, like I contributed to Babel, so I have some resources which can help out to you to get started. These are two blogs by Dan Lee Howe, who was a Babel contributor also. They are great for getting started with contributing to Babel. The Babel Handbook by James Kyle, it is an all-in-one resource to get to know about Babel. So, and Babel issues, they are very well tagged and very well labeled. So whenever you find an issue that has a good first issue label, you can surely comment there that you want to help or you want to help out. The maintainers will surely reach out to you and will assign the issue to you, and you can ask them for any help you want. And Babel has its Slack channel. You can join the Slack channel and discuss with the maintainers about anything. These are some resources that I referred to. Babel Docs, Babel Handbook by James Kyle, it's really great. Babel How to Talk by Nicolo Ribaudo, he's a Babel maintainer. It was like a really nice talk. He implemented a full optional chain plugin in that. You can surely give it a look. Demystifying Babel by Sven Swallow, and a talk by Henry Zhu. Babel README and Wikipedia. So thanks, stay safe and healthy. And you can find me at my website. And these are my GitHub and Twitter links. Thanks a lot.
Thank you very much. It was really good. You can put your camera now. It's okay. I really enjoyed it, and I enjoyed the fact that you know so much stuff about Babel. It's incredible. Let me see. Is there any questions you would like to ask a friend here? It's quite late, so we have to all understand that he did that very, very late in his time.
No, it's a privilege to me actually. Thanks.
How did you think of creating that plugin? What made you create that plugin for Babel? Because that's how did you start learning about Babel, basically?
Okay, so I was like somewhat interested about compilers, like how do programming languages actually work. So one of my college seniors, he actually suggested me to like contribute to Babel so that you can understand how compilers actually work. So I reached out to Nicolo. He is the Babel maintainer, and I asked him like, how can I get started? He mentioned the same resources that I mentioned in the slide to me, and he said that you can read these blogs and you can watch my talk. And after that, he assigned me an issue, and I started contributing to it.
How long did it take you to learn all the stuff? Did it take you a long time?
He said, like, I asked him the same question, and he
Yeah.
said that it will take you lifelong time to like make you realize that you know everything to start contributing. He said that just jump in, just start contributing, and you will learn everything on the way.
What is your advice to other people then?
Yeah, I mean, we have this thing like I'm not ready to contribute now, but like we can start contributing anytime, be it not in the source code. We can start by contributing to the documentation. My first pull request was into the documentation of Babel, so we can start helping out in the documentation, and then we can start working on small issues like, or the good first issues, and slowly, as we get acknowledged with the source code and the code base, we can like take up bigger issues, and like it's all to help them because they are maintaining a very useful project.
Very good. So we are going to have now a break for 5 minutes. If anybody wants to go and chat with Siddhant, You can be on the top right corner table, and I can ask you any questions. We're going to come back with Team and Webpack and low carbon. So it's like all development tools today. It's going to be
Yeah.
really exciting. Okay, I'm going to switch back to the lounge area. I'll see you there. Thank you very much. Congratulations.
Sure. Thanks.
Thank you.